Good afternoon, ladies and gentlemen. We have the final session of the day, final session of the Congress. It's indeed an honour to be here, but also to present this final session. I'd like to thank the organisers, Chairman Mr. Razdan, President Dr. Anil Garg, esteemed colleagues, speakers on the dais, students, attendees, delegates, and those watching on the World Wide Web. The session today is an important one. The reason why it's important, because we need to accelerate the progress that we know we need to make. The progress is too slow. The earth is heating up. Economies need jobs, GDP, revenue. Governments can't keep printing money. So, just going to introduce our panel, and the reason for that is they each have their own skill set and they're each going to make an individual and unique contribution. I'll make some comments after we've had a quick intro, but they're going to have 15 minutes each and maybe slightly more if we don't get a full attendance on the dais. And then we'll have some Q&As, 10-15 minutes if we get time. This is a session for you as well as for us to share with you. We want to learn from your need to learn. We want to answer your questions. And this is an interactive forum, so no question is too stupid. In fact, they're all completely requested. So we have Dr. N.N. Ray, who I'm not Dr. Ray, he's Chief General Manager and Head of Environment for Oil and Natural Gas Corporation Limited, member of the Institute for Petroleum Safety, Health and Environment Management. We also have Ram Vaidyanathan, if I pronounce that correctly, Ram, sorry, you did teach me and I've forgotten the lesson already. Assistant Vice President and Head of Environment Sustainability for Godrej Industries Limited and associate companies. That sounds like a group, so you're probably a very busy man. To join us on the dais, hopefully soon, will be Dr. Sandeep Sharma, General Manager, HSE Medical Area for Indian Oil, and Mr. Samir G. Shah, Senior General Manager in Technology for Technomont PVT Limited. The first thing I'd like to do is ask the panelists that are present on the dais if before we get started and people get too battle-weary with listening to so much technical detail all day, a 30-second takeaway, if they could give us one thing that would accelerate the transition for technologies to net zero, if they could just tell us in 30 seconds which thing that they're going to talk about and why. Just a short 30 seconds, then we'll go through your presentations after that.
It's a really interesting question, and it's very difficult to summarize it in a very concise manner, but if I had to make a wish list, at the top of it would be data and the free flow of data, especially considering we're looking at the agri and forest sector in India, which is one of the biggest components of the entire ecosystem. Data tends to be very fragmented because many times you're dealing with stakeholders as small as a single shareholder farmer in terms of getting data on waste and agri-waste and even the carbon that they're sequestering as part of their plantation. So if I had one wish, it would be to completely streamline the data and have more of an India-focused data set on emissions. We're still using either DEFRA or UNFCCC, IEA emission standards. But considering the vast difference that Indian agriculture operates it in terms of it's a very regulated economy, there's hardly any, there's no deforestation at all. It's all very tightly wound. I think it makes sense to start having much more localized data, localized emission standards as we progress on our net zero journey.
Okay, thank you, Ram. Dr. Ray?
Good afternoon. As you see, the importance of capturing the data is very, very important. As far as the global gas emission is concerned, green gas emission. So that is scope 1 and scope 2, scope 3, as you know, the different forms of emissions as per the GHG protocol. If we are able to capture it, only then we can focus on the specific area where we need to correct corrective actions. So with that respect, capturing of data is really very, very important. Thank you.
As data is concerned, every second we are generating lot of data throughout the world. And these informations are available in our atmosphere. Only thing, we have to gather this data, we have to analyze this data, and we have some inference or some conclusion with this data. This is very important for pollution, for net zero, for our existence also. And that's why most recent technologies, AI, IoT, big data, machine learning, cloud computing, Internet of Things, they play very, very important role. Thank you.
Thank you, Dr. Garg. And to add to that comprehensive agreement about data, I am going to put my vote in the box for data, but for a specific purpose. The three esteemed colleagues on the dais have explained why data is important. But I'll also tell you why data is important, because I believe that confidence from the financial markets, institutional investment, comes from statistical significance of outcomes, and outcomes mean guarantees. And we're going to go through some things today that are missing, that need to be in place for us to accelerate what we're doing in climate change. But the net zero transformation pathways require finance. The institutional investment, the high net worth individuals who want to bring their hard-earned money into leaving a legacy for this planet as they grow older, they've achieved great things, they want to help. But we need to help them to help us. So data is the foundation, and finance is the fuel to drive innovation and the cost of transformation. So I'm just going to run through a few things that, well, 10 things very quickly, very briefly, and then I'll pass over to my colleagues for their wisdom to share with you, 15 to 20 minutes each. Finance, I've just touched on that, 10 key areas to accelerate technical and technological innovation. So when we're talking about finance, we mean $1 billion goes into 200 venture capital trusts. We're talking about incubation, not just putting $1 billion into a tidal program, which is a good thing, but 200 VCTs is going to make a big difference, accelerating the technology readiness level to 7 to 9 so that the banks and institutions can invest. So sort and sift really quickly. Coal activation system, discussed yesterday, greening of coal. If we were to build a retrofit academy program throughout the global south and the coal-based economies, we create jobs for the training, we create jobs for the installed teams, and Economy Solution Group and Coal Economy Solution, our subsidiary, are working with Clean Coal Partner, and the first retrofits going into ASEAN this year. We need to teach and train lots of people. So that leads nicely on to a global skills analysis. No one individually owns this outcome. It's a collective requirement between public and private sector. So we need to train people, but we need to know what to train them in. And we only need to train them in the things we know are going to be required. But we need to know what the data is, to know what it is that's working, so that we know it's required. So this is all fitting together in a very sensible chronological order. Whole Earth carbon accounting. Our biorestoration partner, the only brand you'll find on our business cards at Economy Solution Group is Envisionation. They're our partner, and we have many partners, but they are the one that make the difference. The biorestoration principles to reduce the sulfur dioxide in the atmosphere with diesel and coal decarbonisation will result in a temperature rise of 0.5 to 1 degrees C, almost within weeks, if we do not decarbonise the air, restore carbon to the soils through biochar, biomass pyrolysis, and the oceans. So whole earth carbon accounting, we need a single carbon standard, ladies and gentlemen. But to do that, we need to put every single square meter of living carbon on the blockchain. To do that, we need to have the Earth remote sensing satellite systems. We have satellites, but we don't have the software and systems yet. But once we've got those, we have the data, we need a quantum computer, and we do not have that either, because we haven't identified the need, and we need $1 billion to do that. But we know who can do it, and they're multi-party, third-party vendor independent, the International Centre for Earth Simulation in Geneva. So Envisionation, being led by Brew Pearce, please keep an eye out for him. Go to envisionation.org and join the club. Energy storage, supercapacitors. Graphene economy is coming. We can recycle graphene from marine sludges, waste hydrocarbon oils. We can get it even from sugar beet, from pyrolyzing plant material, waste biomass. We're going to need to have something more than just lithium ion. We may even end up displacing lithium ion because there might not be enough lithium in the world. Pacemakers, lithium medication for bipolar disorder. We can't necessarily provide enough lithium for everybody. And we don't want fires in our waste dumps every day, which is happening in the UK. So supercapacitors, if you use a supercapacitor data service manager, you turn a diesel power generator on and off. When you charge up the supercaps with diesel, you can save over 50% of the diesel by running the supercaps for your auxiliary power supply. This is already being done and achieved in a number of sites, but we need to scale this. The IP owner needs to have investment to build gigafactories, because when you get this, you'll want lots of it, and they cannot supply at the scale that the demand could follow. So we need supercaps to be successful and graphene to be very, very prevalent. At the moment, the vapor deposition method is too expensive, thus it doesn't exist as a viable technology. Marine sludge processing, like the Delscope Slops facility at Jebel Ali for DP World, now there's a facility. And if we multiply that by 60 ports in the DP World portfolio and then all the other ports in the world, we've got ourselves a graphene economy, ladies and gentlemen, and all the waste oils from our garages, from our commercial vehicle processing and maintenance facilities. 100% recyclable wind turbine composites. Vestas is, I would propose or suggest, the biggest wind turbine company in the world. I think they're Norwegian. They've been doing some work with the National Centre for Composites in the UK in Bristol, working with, an expert in nanographene like Trelleborg Applied Technologies. Great company, great professor, research individuals. If we were to grind up glass, get thermoplastics and graphene, put that on the leading edge of wind turbines, we might lengthen the mean time between failure for decommissioning turbines. So at least we get more time with the existing turbines that cannot be recycled. But the recycling of the turbines doesn't exist. They're going into landfill in the States, or they're being cut up and burned, which is an admittance of failure, because we shouldn't be combusting things like that. We should be pyrolyzing them. So moving swiftly on, I'm not even going to mention the steel that goes into wind turbines. Cleaner industrial processes. We do need clean steel. We need to recycle more steel. That means we need better regulation for white goods, the manufacture of steel goods when they're originally made. We need to have regulations about how they demount at the end of their life. Making of aluminium, we need smelting technologies. Mentioned yesterday with the coal to retrieve silver from fly ash. The same technology can be used to improve the concentration of aluminium concentrate to full metal on site. No need to ship the concentrate around the world. The factories can be next to the site of the mining, and then that can be jobs for the local people. Rapid pathway development for the hardest to abate sectors. So we need a combination of all these things for marine, aviation, thinking micro-modular, reactor, nuclear. So triso fuels, very low cost, easy to recycle, 4 megawatt to 10 megawatt block. The problem with nuclear reactors is they're not organized in the sense of harmonized standards. So you have to spend $500 million in the US, Canada, the UK, whatever, to get an approval of the first license, $50 million for a vendor design review. So there are problems with the backstop of long-term renewables if they don't fully deliver, and that's small to medium modular reactors. These could solve the shipping problem. They could also solve a lot of other hard-to-abate energy-intense sectors. Nearly there, ocean flakes, carbon restoration. When you look at the 550 gigaton carbon deficit that is not in the soils, that is in the biorestoration plan aired by Envisionation, written by Envisionation, and upon which the single carbon accounting system will be developed. Ocean flakes are pieces of nanomaterial that get coated, they go into the ocean and they have silicates and ions and other things that the fish can absorb and digest. And then there's a cycle with whales, krill, phytoplankton in the oceans to restore, to oxygenate, to create more nutrients in the black spots, in the hydrogen sulfide dead areas of the ocean. Because if we don't do this, ladies and gentlemen, if we don't create carbon credit revenue for trawlers throwing large amounts of carbon ocean flakes off the back of their trawlers and their vessels, we won't restore the oceans. But we can do this relatively quickly. There's already a $2 million program going on with the Indian authorities off Goa, and this should be scaled to $100 million in the next 2 years and beyond. And the final thing, ladies and gentlemen, I have touched on lithium ion. I'm not a great fan, though I understand we've needed an EV model, but the way it's working out, the scaling of the infrastructure, the doubts over the cost, the heavy weight of transportation, and the lack of, until now, wireless technology to charge EV public transport so you don't need such a big battery, those things have been missing. Now we have scanning technologies. We can spot lithium batteries in the waste feed, waste stock, in recycling depots. And you can get insured now in the UK if you use certain scanning technologies that are available. So by 2050, we believe that 20 to 30% of rare earth elements and critical minerals will come from urban mining. And that also starts with PCBs and all of the electronic and e-waste that we just chuck away goes to landfill. And it's full of precious metals that we need, and we don't have enough of it already. So that's my piece, what it's worth, ladies and gentlemen. I'm going to hand the floor over. I would first like to ask Dr. Ray if you'd like to join us and give us your knowledge and wisdom. Thank you, sir.